Okay, the intercepts of this function are where it crosses. We have x-intercepts, which is where it crosses the x-axis, and y-intercepts is where it crosses the y-axis, or touches in this case. So the x-intercepts obviously are going to be at -1 and 1. Your y-intercepts it's just 1, and it's right there at 1 also. Okay, the domain is the smallest x to the largest x. So the smallest x is at -3, and the largest x is at 3. So our domain is -3 to 3. Our range on this problem is the smallest y, which is 0, to the largest y, which is 2. So this is going to be from 0 to 2. Now, for intervals on where it's increasing and decreasing or constant, I encourage students to draw because you're only going to be talking about x intervals. So put values on your x-axis that are important. And those are the starting point of the domain, which is like -3 to 3, the ending point of the domain. And then any mins or maxes that you have, the x coordinates of those. So like -1 is a min, and at x equals 0, you have a max, and at 1, you have a min. Then you want to describe the behavior of the function between the intervals that you've created here. So from -3 to -1, the graph, the y values are getting lower. So we say that the function is decreasing. From -1 to 0, you can see that the function is increasing. For x values from -1 to 0, the function is increasing. For x values from 0 to 1, the y values or the function values are getting lower, so that's decreasing. And then for x values from 1 to 3, the y values are increasing. So the interval on which it's increasing will be -1 to 0 union 1 to 3. It's decreasing on -3 to -1 union 0 to 1, and it's never constant. Now, to tell whether it's even, odd, or neither, one way to approach it is by looking at the symmetry of the graph. You should see that you have y-axis symmetry, and when you have, because you could fold it, you have a mirror image across the y-axis. So when you have y-axis symmetry, we say that the function is even.